Guess which gas has fastest moving speed? So A, hydrogen gas, B, NO2 gas, C, C2H6, D, they all have same speed. There you at 25 degrees Celsius. This means at same temperature, right? At the same temperature, which gas move fastest? We learn in this chapter 5. Light molecular move faster, heavier molecular move slower. So clearly, hydrogen is the lightest molecular, right? If you take a look at periodic table, hydrogen is the first one. It's the lightest molecular, so hydrogen must move fastest. So this is your answer. Hey, get it? Hey. Second, ask you which gas molecules have the highest average kinetic energy at 25. Still this gas. Okay. Still this gas. Which gas have highest average kinetic energy? Do you remember? This is kinetic model of ideal gas. If two gas at the same temperature, then they have same average kinetic energy. Okay, if you open the book, if you open the PowerPoint slide, right, about the kinetic model or kinetic zero of perfect gas, last one, point 4, okay. At the same temperature, two different gas will have same average kinetic energy. Terry, pick your quiz. So they all have same. Okay, so average kinetic energy. Both at 25 degrees Celsius. So different gas at the same temperature, they have same kinetic energy. Okay. The rest, you need to show work, because I labeled clearly you need to show work for the rest of the problem solving. So question 3, ask how many atmosphere pressure is 820 millimeter mercury. So 820 millimeter mercury converted to ATM, atmospheric pressure. So 1 ATM is 760. You are required to remember this. 1 ATM is 760 millimeter mercury. Okay. So this converted to millimeter mercury is 1.079. Why I kept this 4 significant figure? Because the initial number I gave to you is 4 significant figure. Okay. Some of you give 1.08, that's fine. Okay. No. Or question 4. This is very simple. Very simple. If you still didn't get it, you didn't listen at all in class. This is simple is the problem solving for this chapter. I would say cannot be easier than this. Question 4 asks you how many moles of gas occupy 21 liter at 25 degrees Celsius and 2.3 atm. Ask you moles. Get it? Ask you how many moles of gas would occupy 21.0 liter at 25 degrees Celsius and 2.3 atm. Volume, pressure, temperature. Ask you moles, and you need immediately think about use ideal gas equation, right? As I said, gas problem solving. Always think about ideal gas equation. Now tell you pressure, tell you volume, and the temperature. Ask you calculate the N. R is a gas constant. I provide you this number. Yeah, right? For this equation, everything else are non-value. Also, you calculate the N. It's easy. This is the same thing. At the first day of this semester, I ask you, everybody must know how to solve this equation. Right? It's the same. How to solve for N, and both sides divided by RT. Both sides divided by RT. So N equals to PV divided by RT. Okay. First day of this semester, I ask you, you are required to know how to solve this equation. Some of you laughing. But unfortunately, again, we have a couple of students didn't solve this. We have students N equal to RT over PV. Okay, how can this be? I think you didn't double check. So some of you have some time left. You can double check. If you double check, you can easily find this is a very simple mistake. Cannot be. So N equal to PV divided by RT. Now just plug in the number. P is 2.3 atm. V 21.0 liter. R, I provide you this number here. Some of you changed it. You need to use the one I provided. Why you change it? 0.08206 liter atm per mole per P times T. Gas problem solving. This T must be in Kelvin. The reason is this R is per mole per K, not per mole per Celsius degree. Okay, so temperature must be in Kelvin. 25 plus 273.15. Okay. If you use plus 273, that's fine. Okay. So use calculator, you can easily get the mole is 1.97 mole. Okay. It's question 4. Then question 5. A tank contains 6 more neon and 2 more oxygen. As you calculate more fraction of oxygen, more fraction we use X. More accurately, this letter is not X, it's chi, Roman number chi. Okay. Looks like an X. You can read it, it's just X, it's fine. The mole fraction of oxygen, defined as moles of oxygen, right? Moles of oxygen over all moles or gas, right? The moles of oxygen is 2. Moles from all gas, then 2 plus 6. Is this easy? This cannot be easier than this. Is there any unit? No unit. This is moles, this is moles. If you write here is more divided by more, it's cancelled. This is a pure number, 0.25. B, if total pressure of the tank is 620 millimeter mercury, what is the partial pressure of the oxygen gas? The partial pressure equals to mole fraction of this gas times total pressure, right? Mole fraction we just calculated 0.25, and the total pressure tell you 620. Then your answer will be 155 millimeter mercury. You can use this because I didn't ask you convert to ATM. You can keep use millimeter mercury. Of course, if you convert it to ATM, that's fine. This is actual. No actual credit. If you convert it, if you correct, yeah, I still give you. But if you convert it to ATM, this is the wrong thing. You may lose one. Okay, so how can we convert this into ATM? Same as here. One ATM is 760, right? So we just divide by 760 will be ATM. Again, not required because I didn't specify what's it being ATM. So you can keep use millimeter mercury. Question 6. What would be the density of fluorine gas at standard temperature and pressure? Also, you calculate the density. Okay. So density equals to P pressure times molar mass over RT, right? This is the formula. Do we know P? Yes. STP means standard temperature and pressure. So standard temperature and pressure means 0 degrees Celsius. Of course, you need to use Kelvin. Pressure is 1 atm, right? So pressure, temperature, both are known value. Pressure now, temperature now, R is a gas constant. I provided you the number here. The only thing you need to figure out is the molar mass of this gas. Molar mass, tell you formula. I provided you a periodic table. So use periodic table, find the atomic mass times 2 because F2 is molecular, right? So atomic mass is 19. The molar mass will be 19 times 2. P is 1 atm. Molar mass is 19 times 2. Unit is gram per mole. Or gas constant, just use this value I provided. Don't change it. T use 273.15 K. If you use 273, that's fine. This one be 1.69 gram per liter. Okay. Or alternative way, if you remember, one more ideal gas volume is 22.4 liter at STP. If you remember this, textbook has this, right? One more and ideal gas at STP volume is 22.4 liter. Then you can also use this method, M over V. One more ideal gas volume, then one more ideal gas is a mass, right? This is molar mass. So molar mass is the same as here, 19 times 2. This is molar mass is a gram per mole. This is a 1 mole, the volume should be liter per mole. So 22.4 liter per mole. Then you get the same answer. You get the same answer. So either this way, use the formula we learned from textbook, or use this. Okay. Then question 7. Most of the problem come from here. Okay. At 97 degrees Celsius, pressure 780 millimeter mercury, 2.5 liter gas. The mass is 3.55 gram. So 2.5 liter gas with 3.55 gram. Ask you the molar mass. Ask you calculate the molar mass. Okay. So actually, it's a similar formula here. Use this to calculate the density. Then rearrange this equation, you get molar mass. Right? So both sides times RT, then dRT, then both sides divided by P is molar mass. So molar mass will be dRT over P. Okay. R gas constant, no value provided here. Right? T, 97 degrees Celsius, convert to Kelvin. Anyways, non-value. P, 780 millimeter mercury. You need to convert to ATM because the value of R is per liter ATM per mole per K. This means the pressure must be in ATM. Okay, anyway, it's non-value, right? If we know D, then we can calculate the MW. Here didn't tell us D directly, but tell us mass together with volume. So we can calculate the D. D is mass over volume. Right, this is the definition. So mass is 3.55 gram, volume 2.5 liter. So this gives you density is 1.42. Now we can calculate the molar mass. So molar mass equals to dRT over P. D, we just calculated 1.42. R gas constant, use this number directly I provide you. Again, don't change it. Okay, if this is standard test, if you change the value from the instruction, then you probably get a wrong answer. No credit here. You change a little bit. If your final answer is pretty similar, I'll give you credit. But keep in mind, whatever number provided, you must use that number. You have no sense you change it. R 0.08206 liter ATM per mole per K. Then T must convert to Kelvin, so 97 plus 273.15. Again, if you plus 273, it's fine. Then P must use millimeter mercury converted to ATM, so divided by 760. Again, why we need to convert millimeter mercury into ATM? Because this R is liter ATM, not a liter millimeter mercury. Okay. Why we use this temperature in Kelvin? Because the liter ATM per mole per K, not per Celsius degree. Okay. So you'll find ATM concept, K per K concept, and the liter concept is per liter. Leftover gram per mole is a unit we want. So molar mass is a gram per mole. So this give you answer is 42 gram per mole. Okay. This method is straightforward because we have a formula is mw equals dr over t. We have several students working another way. Then follow what I explained in the class. That's fine. So this student follow this way is use ideal gas equation. Use ideal gas equation. And here tell you pressure, volume, right? Temperature. R is gas constant, so we definitely can calculate the N moles. When we calculate the N, then mass divided by moles give you molar mass. Okay. N will equal to PV over RT. P, again, this P, you also need to convert to ATM. It's the same because R is based on ATM. V is liter, 2.5 liter. R, use a number I gave to you. T, similarly, you need to convert to Kelvin. So 97 plus 273.15. So this will be 0.08447 more. Then molar mass will be mass divided by mole, right? Molar mass is mass divided by mole. And I always write in this place, right? Because mass to mole is mass divided by molar mass. Mass divided by molar mass is more. Then molar mass is mass divided by more. Right? We just switch this to. So mass is 3.55 gram. More, we just calculated 0.08447. Right? Gram more. Gram more. So this will be same. You get the same answer. Okay, are you okay for this? Do you have any question about the quiz 5?
For number 5, I put 104 for A and 155 for B, and I showed my work, and he took all 4 points.
Come here.